Hello students, today we are going to start with the coordinate geometry concepts. So the first concept is the distance formula, right? So let's say we have 2 points. This is first point A, this is second point B. This point has coordinates x1 comma y1 and this point has coordinates x2 comma y2. Now if I am interested in the distance between these 2 points, then we will see how to find out this distance. Now as these points coordinates are given to me, let us draw here axis, right? So if I have to find out distance between these 2 points, first thing which I have to do is to drop a perpendicular from A point on x-axis, right? Similarly, I will drop a perpendicular from B on x-axis, right? So this is, let's say, L, this is, let's say, M. Now I am interested in this distance. I don't know anything about it. I don't know the distance formula yet, right? So what will I do here? I dropped here perpendiculars from this point on x-axis. Now what will I do? I'm going to join this, or you may say I'm going to draw a perpendicular on this BM. So let's say this is C. Right? I hope this much is clear. Fine. Now my question is, if I have this AC length, let's say, and this BC length, can I find out this AB distance? Yes or no? Yes, we can. Why? Because this is a right angled triangle, right? As this is a right angled triangle, if I have this length, then I can find out this length by Pythagoras, because we know perpendicular square plus base square will be equal to hypotenuse square, because this is behaving like the hypotenuse of this right angle triangle ABC. Alright. So my purpose is here to find out first of all length AC and then length BC, right? So can you tell me how much is this? If you remember, we have done this in our junior classes. In class 9 also, if you have done coordinate geometry, then you must know that the horizontal or the perpendicular which we are drawing on y-axis will give us x coordinate, isn't it? So x1, this much is how much? X1, right? How much is this? X1. So let me write it with some other color. So this much is x1. Similarly, if I will ask you, let me write here something, some name, let me give it. Let's say this is t. So if I will ask you this much, can you tell me how much is this? Yes, very right. If you see, this is its x coordinate is x2. So this much is from T to C is x2. This is your x1 and this is nothing but x2. Now quickly tell me what will be AC. Now you have this much length and this length. So you can write this as x2 minus x1. Right? Right? Now we are interested in this BC. I will be able to write down this BC if I will find out this BM and this CM. If I will subtract CM out of BM, I'll get this BC. Now if you see, how much will be BM? BM is what? Vertical line, perpendicular dropped from this point on x-axis. This will be what? The y coordinate. So it means this BM will be how much? Y2. Right? And this CM, if you see, CM, or you can say this AL, both are same. right? Both are same. So if you see this AL, how much is this? This is again a perpendicular dropped from this point on this. This is how much? Y1. So as this much is Y1, so this much will also be Y1. So this whole was Y2, this was Y1. So this much will be Y2 minus Y1, right? This length will be Y2 minus Y1. Now I have this AC length, I have this BC length. So now using Pythagoras, let me write here how did we found AC. AC is TC minus TA, which is x2 minus x1, and BC is BM minus CM, which is y2 minus y1. Now, by Pythagoras, right? By Pythagoras, let us use here AB square will be equal to AC square plus BC square. So how much is AC? AC is x2 minus x1 whole square, and BC is y2 minus y1. So its whole square is there. So we will put here. We are interested in AB length. We are not interested in square. So to remove this square, we have to take square root on both sides. So let us take square root. So what did we get here? We get here the formula, which is distance formula. This is what? Distance formula. All right. I hope you understood how did we get this distance formula, right? Now let us do section formula, right? I hope all of you know the similarity concept, because for this we need to know what is similar things, or what are similar things or similarity of two triangles, right? So let us draw here. First of all, again we have 2 points, A, this is B. The coordinates are x1 comma y1, x2 comma y2, right? So for this I am drawing here axis also, right? This is origin. Now let's say in between there is a point, let's say this is P having coordinates x comma y, and this P point is dividing this segment into the ratio m1 is to m2, right? m1 is to m2 ratio. I hope this thing is clear. Now what will be there? I am given this point and this point and the point dividing this segment into the ratio. These things are given to me. I am interested in this x and y. All right. What are we interested in? We are interested in this point P. Clear? Now after this, again the same process we will do here. We will draw perpendiculars on x-axis. So let us draw here this perpendicular, and this perpendicular. We dropped here these perpendiculars, and I'm going to name it. This is A, B, and this is P. So let's say this is M, N, O, right? M, N, O. Now, as I'm interested in this, what I'm going to do, I'm going to draw a horizontal line here, right? This one. And here also. So if you see, I'm getting these 2 triangles, right? So let me give it name. This is your, let me write here, this is B, x2 comma y2. Let's say this is T and this point is S, right? And this point is L. Fine. Now why this came in my mind? The reason is, here if you see, the ratio is given to you, and whenever there is ratio, most probably the similarity concept will help us, most probably. Okay? Not everywhere, but most probably. So here this concept this concept brought this in my mind, that I have to use similar triangles. And if you see these two triangles, can you see these two triangles? And what about these two triangles? What can you say about these two triangles? If I'll say AL and P, triangle ALP and triangle PTB, what can you say about these two triangles? They are similar. Very right. If you see, this is right angle triangle, these two triangles are right angled triangles. So one angle is this, which is equal. Alright. Second thing, if you see this angle and this angle, what can you say about these two angles? They will be equal. Alright. These two angles are equal. So what did you see? Now I think you know that if we have to prove two triangles similar, then we can make any of the two angles equal, or we can write all the three sides ratio. If we are getting equal, then also we can say the triangles are similar, or SAS criteria. I hope you know all these criteria. So here what did we use here? Angle criteria we used to make these two triangles similar. Alright, now we know all these things, that these two triangles are similar. So let me write here, triangle ALP is similar. ALP. Now A is equal to this P, so I am writing here P first. This L is 90 here, T is 90, so I will write here T, here B. Keep in mind, you cannot change the position of these letters. You have to write on PTB if you have written here ALP. If you will write here APL, then you will write here PBT accordingly. Now, as these two triangles are similar to each other, so what can we say? These triangles sides ratios is proportionate. So I can write here AL upon PT is equal to LP. What I did here, I took first these two, then these two, these two, these two. Then I will take first last, right? So what I got here, AL by PT, LP by TB is equal to AP by PB. If you will write triangle nicely, then you will not face any problem in writing this ratios, right? And you know here AP by PB is given to you. How much? M1 by M2, right? M1 by M2. I hope till this it's clear to you. Now after this, what can we say here? That AL upon PT is equal to M1 by M2. Similarly, I can say here LP by TB is also equal to M1 by M2. M1 by M2 from this. Fine. From this we got. Now, after this, if I will be able to write here ALPT, the lengths of these LP and TB, then I will through. So let us write first of all AL means this much only. How will I get? If I will get, I have this much and this much. From this, if I will subtract this, I will get this. The same concept. If you see, this much is, if you see, this is X, isn't it? This is X. So X minus X1. X minus X1. Fine. So AL is X minus X1. PT. PT. This much. If you see here, how much is this? It's X coordinate. If you see X2. Out of this you have to subtract this. So how much is this? X. So X2 minus X. x2 minus x. Alright, x2 minus x is equal to m1 by m2. Now let us do the cross multiplication, because I am interested in x. Alright, so let us cross multiply it. What are we getting here? m2x minus m2x1 is equal to m1x2 minus m1x. Right? So wherever x is there, I will keep them in one side, and other terms, because x is to find out, so we will keep them in one side. So I am bringing this x term in this side, m1x2 plus m2x1. So from here x is common, so what I got here, m2 plus m1, you may write m1 plus m2 also, m1x2 plus m2x1, and then after this x I got here, m1x2 plus m2x1 upon m1 plus m2. So this is x coordinate, p is x coordinate. Alright, similarly if we will move with this LP, now I am going to take this LP upon TB is equal to m1 by m2. The same way, now LP, if you see LP, this much. So now vertically we have to move. From this, if I will subtract this ln, from this, if this is what? Pn. Out of Pn, if I will subtract ln, I will get this Pl. Right? So how much is this? This is y, and this is y1. So y minus y1. So let me write here y minus y1. Now TB, this much. If you see, out of this, if I will subtract this much, I will be through. So how much is this? y2. So y2 minus, how much is this? If you see, this is y. So this much and this much is same. So I can write here y is equal to m1 minus m1 by m2. Now again, when you will solve it, I am not solving it completely. So you will get here y is equal to m1 y2 plus m2 y1 upon m1 plus m2. So what did we get here? We get p, the coordinates, m1 x2 plus m2 x1 upon m1 plus m2, comma m1 y2 plus m2 y1 upon m1 plus m2. And this division is internal. We will study only internal division. External division means this point will not be here, it will be outside somewhere. On this line only, but outside. Right? But in our syllabus only internal division is there. So this is what we were interested in. I hope you understood all the concepts. Revise it properly, because it will help you in solving sums. So thank you so much all of you.